The purpose of this video is to determine if data has a linear relationship or if it's more of an exponential relationship. The first thing that you're going to want to do is enter in all your data. The x values would be in the first column, the y values would be in the second column. The next thing you're going to do is select both columns, all the data. You don't have to include any titles at all. If there's titles in the columns, just select the numbers, the values, and then click this next icon right here and select two variable regression analysis. The first thing we're going to do is add in a linear regression. So you're going to move down here where it says regression model and change none to be linear. So you see your line of best fit added to your data. The equation for the line of best fit is down here, y equals. And then to get your R value, which will determine the strength of this correlation, is going to be determined by clicking the sum of x. And then your R value is going to be right here, 0.8806. Now, if you want to add in an exponential regression, you're going to go down here to the regression model, and you could click exponential, and as you'd see, your curve, or I should say your line of best fit, doesn't look like a line anymore, it's more of a curve, and that would be the exponential regression. But if you look down here, the equation has a base of e. For the sake of writing an equation that looks like the one in class, you're actually going to change the regression model to be growth. So then now if you look at your equation, the base of e is no longer there. The base is 1.0109, so this is going to be about a 1% growth. That's where you're going to use for the equation of best fit for an exponential growth. And then you still have your sum of x key selected here, and you could look at the r squared value, which would determine the like how good this data reflects a exponential equation. So that r squared value is 0.8123. That is farther from 1 compared to the r value. When you switch to a linear model, the r value was 0.8806, so that is closer to 1. That's why we're going to stick with a linear regression. That would be a better explanation for the relationship of the data. The data would be more linear than it would be exponential because the r value is closer to 1 compared to the r squared value when I change it to growth, which is just 0.81.